Hey guys, it's Mr. Gibson. I'm going to show you guys how to complete the square as a review. So this will be real quick, not really teaching you guys how to do it, just trying to refresh your memory through a few examples. So look, we have a problem like this. We want to solve for p. Before we could possibly factor it or do any number of things, but I'm just going to show you guys how to complete the square. The first thing you do to complete the square is we're going to look at this number, this coefficient, always next to the variable without an exponent or an exponent of 1. So 10, and I'm always going to divide this coefficient by 2. 10 divided by 2 is 5. And then I take whatever I get with that and I'm going to square it. So 5 squared is 25. Alright, so what I'm going to do with this 25 is I'm going to add 25 to both sides. And I'm going to show you guys why this is important and why this is such a good trick. Alright? So I have negative 3 plus 25. Okay, why this is a good trick is now I'm just going to isolate this part right here. And I'm going to factor this part. So that's what multiplies to get 25 and adds to get positive 10. The two numbers are 5 and 5. So it factors like this, which is nice because this also simplifies to p plus 5 squared. All right, let me put everything else that's in this equation together. So plus 13, that just bringing that down. Negative 3 plus 25 is 22. Alright, so why this is nice is because I can use the square root, the inverse of a square root, to solve this. And I'll show you guys how. So first I'm going to subtract 13. Alright, so 22 minus 13 is 9. Now to get rid of this square, I'm going to square root. I get p plus 5, because that'll get rid of the square, equals plus or minus, well, the square root of 9 is 3. Okay? Now, what this means is p plus 5 equals 3, and p plus 5 equals negative 3. So let me solve this equation, subtract 5 on both sides, and get p equals negative 2. Subtract 5 on both sides here, and I get p equals negative 8. Okay? So the key to doing all this is taking this number next to this coefficient, which is next to the variable without the square, dividing it by 2, squaring that, and then you have this nice pattern that happens where you can where you end up with a perfect square right here when you factor, and because of that perfect square, we can square root to solve. Okay? So let's see a couple more examples where we won't have a perfect square when we get to this step right here where we square root. Okay? Alright, so here again, we're going to look at this. We're going to look at this negative 12. So I'm going to take negative 12 and divide it by 2. It's negative 6. Have negative 6 squared is 36. So let me add 36 to both sides. Plus 36 plus 39 equals 6 plus 36. Isolate this part. What multiplies to get 36 adds to get negative 12. Here's another trick to this. This part will always factor to this factor right here, this negative 6, okay, or whatever you got when you divide it by 2. That's the whole trick to this, okay, is that this nice relationship when you divide by 2 and then square always works when you factor, okay? But anyway, multiplies to get 36, adds to get negative 12. Well, that's x minus 6, or x minus 6 squared, plus 39 equals 42. Okay, I'm going to subtract 39 on both sides. I have x minus 6 squared equals 3. Alright, we want to get rid of the square now, so we square root. So we get x minus 6 equals plus or minus 3, square root of 3. Well, the square root of 3 is not a perfect square, so I can't really break it down anywhere from there. So I'm just going to, again, just add 6 here and I get 6 plus or minus the square root of 3, and that is our answer. Okay, because it's not a perfect square. I can't break down 3 in prime factorization any more than it already is, so we just leave it like that. All right, one more where we're going to have to do a little extra work with some prime factorization. We kind of made a mistake here getting you guys to see 12 twice, but y'all get the idea that, again, I'm just dividing by 2 and squaring. So like the last problem, we actually end up adding 36 to both sides. All right, minus 96 equals negative 8, okay? Isolate this part, factor this, and I'll get p minus 6 squared. Okay, minus 96 equals negative 8. All right, so I add 96 to both sides. I get p minus 6 squared equals 88. I'm going to square root, get rid of that square, and I get p minus 6 equals plus or minus the square root of 88. All right, so what I can do with 88 though is I know it's not a perfect square, but I can break it down into its prime factorization. So I know 8 times 11, I've got 2 times 4, 11 can't be broken down any farther, 2 and 2, 2 and 11, okay? So I know that a square root is a number times itself. A square is a number times itself, so the square root undoes that. It takes a number times itself and gives you the original number. Well, I see a number times itself right here. So I know when we square root 2 and 2, which is 4, we'll get 2 out of it. So I'm going to write this as plus or minus 2. So this 2 comes outside the square root, equals, and then what's left over in here? 2 times 11, okay? P minus 6. All right, so P minus 6 equals plus or minus 2 square root of 22. Add 6 to both sides again, and I get 6 plus or minus 2 square root of 22, okay? Not a perfect square, but it was broken down a little bit. So occasionally you'll have to do this little prime factorization work to look for a number times itself. So I found this 2 times itself, took it out, left what's up over underneath, okay? So that's how you complete the square. Notes will be on the next page, and make sure you guys do the assignment. Thanks.